My esteemed listeners, this tutorial elaborates another algorithm, graph-based algorithm, which is developed on dynamic programming algorithm design strategy. The algorithm is all about solving all pairs shortest path problem. That means this algorithm, when implemented over a directed or undirected weighted graph, will find out the distance between any two vertices selected at random. Therefore, the algorithm is named as all pairs shortest path problem. And this algorithm is due to Floyd's, and in honor of this mathematician, it is called Floyd's algorithm. It is founded on dynamic programming strategy. It's all about finding shortest distances from each vertex to all other vertices in a graph. It could be directed or undirected. The algorithm, after n iterations, records the lengths of shortest paths in a n by n matrix D called distance matrix. Of course, as we assumed or promised that dynamical programming strategy will always have overlapping solutions and it needs initial solution. The initial solution as far as this algorithm is concerned is the weight matrix. The weight matrix. Unlike Warshall's algorithm, which started from adjacency matrix, Floyd's algorithm will start from weight matrix. Weight matrix is the seed value that is given to the algorithm, that is Floyd's algorithm. Okay, the basic principle or basic idea of this algorithm is, if Vi is one of the vertex and Vj is another vertex and Vk is another vertex, and if we want to find out the distance between Vi and Vj, we will just calculate this, or this is available maybe directly in the weight graph, or it may be arriving from the previous solutions. And this, if this is minimum, this will be selected, or some of these two distances may be selected. Of course, Vi, Vj, the jth vertex may be reachable from ith vertex directly. And here the path is shown to be some sort of a zigzag to connote it is not a straight distance, because there is no question of arguing that this distance can be, if at all this were to be straight, this distance should always be short, because straight is always short. Anyway, this zigzag path represents some kind of a tortuous path between ith vertex and jth vertex. Okay, there may be a pond, there may be a small hillock. Okay, the road might have taken all rounds and beaten about the bush, and it has reached Vj. Or it will just add up the distance between Vi and Vk and Vk and Vj. And if the addition of these two distances happens to be lesser than this will be selected. Anyway, the minimum path length between ith vertex and jth vertex selected at random in a graph happens to be the minimum distance, direct distance between ith vertex and jth vertex in the k-1th matrix, k-1th distance matrix, or sum of the distances of ith to kth vertex and k to jth vertex. Okay, this will be added, and it is succinctly shown here in the form of a rule. So dfij in the kth distance matrix is equal to minimum of dfij in the k-1th matrix, or comma dfik k-1 plus dfkj of k-1, where k is greater than or equal to 0. We will just try to understand this simple algorithm. Of course, trying to solve some kind of a very significant problem, significant solution is coming to be very easy, as you can understand, because the essence of this algorithm happens to be this particular equation. Therefore, we will take up this example. This is the directed graph with 5 vertices, and this is the weight matrix. A to A, no connection, and the weight is 0. A to B, it is 4. A to C, there may be a connection, and if at all there is a connection, it should be infinity, like that. And for indirect connections, that means non-trivial connections, we are going to place infinity, and for A to A, B to B, C to C, we will put 0, and it will never change. Okay, throughout the process it should not change, it should remain as it is, because there are no self rules. self loops, sorry, and B, everything is recorded here. And like Warshaw's algorithm, first of all we will select the first row and first column. This row is selected, so this is kth row, and kth column. Kth row and kth column is selected, and horizontal lines are drawn from the weights. Here is a weight and all other entries are infinity, therefore there is no question of drawing horizontal lines from here, and we will draw one vertical line over here from 4, and it cuts two distances, okay, that is along this row and along this column, okay, ith row and jth column, and this happens to be 2, okay, sorry, this happens to be 4 plus 4, 8 it should have become, but already available distance is 4, therefore it will be retained as it is. So therefore in the there is no change as far as d1 is concerned, okay. So d1 remains to be d0 only without any changes. So we will just carry forward and we will take this as 1, and it will come as we will just enter that 0, 4, infinity, 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 okay, and infinity, 0, 3, infinity, infinity. This is again infinity, infinity. We are carrying forward, that's all, okay, recording the k minus 1th matrix. And interestingly there are no changes over here upon selection of first row and first column. Anyway whatever that is availed we will just carry on with, okay, 4, 4, infinity, 2, 0. Now we will select second row and second column, okay, we will select second row and second column, okay, and as usual we'll try to find intersecting points, okay, drawing horizontal lines from the rows, okay, wherever numbers are there, wherever weight values are there, and here we can draw 3 horizontal lines and 1 vertical line, because there is only one weight over here which will pave the way for calculating the distances. Now we will add 3 plus 4 is 7, therefore infinity is removed and 7 is added, and here it is 3 plus 2, 5, infinity is removed and 5 is placed in the next matrix, and it is 4 plus 3, so this will become 7. Therefore we will carry forward and we will generate the next matrix, that is the kth matrix from the k minus 1th matrix. So this happens to be d2. So d2 will carry along with it with the whatever the distances that are previously availed in d1, okay, d1, and I will just record that 0, 4, 7, infinity, infinity, 0, 4, 7, infinity, infinity, yeah, and here infinity, 0, 3, infinity, 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 yeah, infinity, 0, 3, infinity, infinity, right, and infinity, infinity, 0, 5, infinity, 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 0, 5, infinity, and infinity, 2, 5, 0, infinity, infinity, 2, 0, 5, infinity, 2, 0, 0, this should be 0 actually, yeah, 5, 0, yeah, sorry, it is 5, 0, infinity, 5, 0, infinity, 4, 4, 7, 2, 0, 4, 4, 7, to 0. Yeah. Now once again we will select as usual the third row and the third column. Okay, third row happens to be this. Okay, third row is selected and third column is selected. There are few numbers available, therefore some changes are going to take place in the next matrix. Okay, now we will draw horizontal line from here, from 7 crossing 3 and crossing 5, crossing 7, and here we can draw once again only one line, okay, piercing through 5. Therefore 5 plus 7, it is 12, but already 2 is there, therefore it should not be changed, and this comes under loop, therefore there should not be any change over here. It remains to be 0 because it is a diagonal entry, and as far as this is concerned, 3 plus 5, this becomes 8, and this becomes 7 plus 5. 7 plus 5 is 12. Definitely it is lesser than infinity. Okay, so two values have been changed, and it has to be carried forward to D3. Okay, we will just carry this forward to D3. So D3, as far as D3 is concerned, whatever the changes that have happened in D2 will be brought up over here. 0, 4, 7, 12, infinity, and infinity, 0, 3, infinity, 8, 8, infinity, and infinity, infinity, 0, 5, infinity, and infinity, 2, 5, 0, infinity, 4, 4, 7, 2, 0. So two changes have happened, that is 12 and 8 have been carried forward. Next we will select the fourth row and fourth column. Fourth row and fourth column is selected. Okay, if you select that, there are two vertical lines we can draw from 2 as well as 5, okay, connoting jth columns, and this is ith row. We can draw from here, we can also draw from here, we can also draw from over here. Now we will carefully have to go through now. Anyway, changes will happen only this side because here there is an infinity. Okay, now 12 plus 5 is 17, it's 7, that is already there, therefore that cannot be removed because 7 is the shortest distance between I and j, and 12 and 2 it becomes 16, it is 4 already, therefore let us not change this. 8 plus 5 is 13, it is 3 over here, and this cannot be changed. 8 plus infinity, that remains to be infinity, let us not change over here. Anyway, and 5 plus 5 is 10, anyway this should not be changed. 5 plus 2 is 7, this is going to change, this is going to become 7, and 5 plus infinity is infinity. So only one value got changed, therefore we will carry it forward. We'll carry it forward again. We'll carry this. Okay, so D4 happens to be this. 0, 4, 7, 12, infinity. The infinity, 0, 3, 8, infinity, infinity, 7, 0, 5, and infinity, 2, 5, 0, infinity, and 4, 4, 7, 2, 0. Now in this we will select the fourth row and the fourth column, fifth row and fifth column, fifth row and fifth column. So none will change here again. none will change here again, because we cannot, there is nothing like drawing lines from infinity, and here there are numbers, but anyway, since we cannot draw any horizontal lines, this is the final matrix. So D4 equal to D5. So what is the contention of this? Okay, there are few infinities left around, and we will just investigate as to why still some infinities remain. And we will take an example. This is A, B, C, D, D to A. If you go to the graph, there is no way that we can go to A. So D to A is infinity, that remains to be infinity, and that is a question of reachability. Okay, my dear friends, this Floyd's algorithm will also tell us reachability, but reachability, a fine-tuned reachability, if at all it is reachable, it will definitely give the shortest path, shortest distance, and we will investigate this. This is BE. Okay, there is no way from B to E also. Okay, we can go to B to C, C to D, we were stuck up over there because there is no way to go to E. So E is not connected to anywhere, therefore wherever infinity remains, they are not connectable, they cannot be connected, and whatever that numbers arrive, okay, that is the shortest path that is available. In a typical graph, something like this, we will get a fine-tuned matrix, something like this, a very small graph we will consider. Okay, and definitely it has to give us some kind of a total answer wherein every other vertex is reachable except one of the vertices that I am going to place it over here. This is D. So B and A is connected, and let us say A and C is connected, and C and D is connected, and D and A is connected with some weight. Okay, anyway, connection is all the more important. Okay, then only we can find out the shortest distance. So if this is 7 and this is 2 and 3, okay, and this is 6, let us say, this is something like 1, therefore every other vertices is reachable, but D remains to be aloof. We cannot go from D to B. Okay, we cannot either come from, we can come from B to D. Okay, there is a path B to A, A to C, and C to D. Okay, this kind of a graph will have minimum number of infinities when compared to previous graph. Anyway, in order to obtain a complete matrix with minimum distances, okay, the graph needs to be fully connected. Okay, I repeat, the graph needs to be fully connected in order to obtain all the entries in the distance matrix to be some numerical values, which happens to be the shortest distance between those two vertices at random. Okay, therefore with this we conclude Floyd's algorithm. Anyway, this Floyd's algorithm cannot take up weights, negative weights. Of course, negative weights will arrive in computer network domain that may represent negative energy between two resources. Okay, anyway, that cannot address, Floyd's algorithm cannot address if at all the graphs comes with negative weights. And of course writing negative weights on a graph is very rare, except in some data communication networks. So with this we will conclude, and I will next we will take up greedy strategy. Okay, greedy strategy, one of the famous strategies. Okay, that is our next tutorial. Until then, bye.